Hi everyone, welcome back to my channel. Now we'll continue with the exercise 2.5. So ABC is an equilateral triangle. Question number 6, we need to do it. ABC is an equilateral triangle with sides 2A. The sides are 2A. Find each of its altitudes. We need to find the altitude. What is its altitude? So solution you can write now. Sixth question. Solution. So to find the altitude. Altitude means it will be always perpendicular to the base. I can call it as P now. So when AP is the altitude, it is perpendicular. Then we can take this as AP only. And this will be half. In an equilateral triangle, the altitude bisects the opposite side. So this will be only A, because it was 2A. Now we can consider the triangle. In right angled triangle APP or APB or ABP. In right angled, first you can write AP is perpendicular to BC and BP will be equal to CP will be equal to only A. Now you can write in right triangle. Either you can take APB or you can take APC also, no problem. The hypotenuse here is AB square is equal to BP square plus AP square. So we know here AB, that is 2A whole square. BP is A square, we don't know AP square. So this is 4A square and bring this A becomes A minus A square is equal to AP square. So 4A square minus A square is 3A square is equal to AP square. AP is nothing but the height, or you can also call it as H. So AP square is equal to, or AP is equal to root 3A square. So only for A, root and square gets cancels. Therefore altitude AP is equal to, or you can also call it as height, is equal to root 3A. The altitude here is root 3A. That completes the sixth question, children. So next we'll move on to the seventh question. We'll see what it is. All the questions are based on Pythagoras theorem or converse of Pythagoras theorem. So next we have prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. So the question number 7, we'll prove it now. This is rhombus AB, CD. We know that according to the property of rhombus, all the sides are equal. Only difference between the square and rhombus is here the angles, opposite angles are equal. There all the angles are equal to 90 degrees. Now what they tell here is AB square plus BC square plus CD square plus AD square is equal to AC square plus AD square. That is what is to be proved. Prove that the sum of the squares of sides of a rhombus is equal to the sum of the squares of its diagonals. First you write given, children. Given is ABCD, or you can write AB is equal to BC equal to CD equal to AD, because it is a rhombus. Next, AC and BD are the diagonals. AC and BD are diagonals. So to prove, what we need to prove? AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square, children. So the diagonals here bisect each other perpendicularly. According to the property of rhombus, the diagonals bisect each other perpendicularly. That means the angle formed there will be 90 degree at the intersection of the diagonals. So proof will take first one triangle. There are 4 right angle triangles. We'll take one triangle, that is AOB. I am going to take. According to that, AB is the hypotenuse. So by Pythagoras theorem, in triangle AOB, you can write AB square is equal to AO square plus BO square. So this is what we got it. So we are going to call it as equation 1. Similarly, we can write AD square. I will take BC square is equal to BO square plus CO square. BO plus CO. This is equation 2. Similarly, we can write now CD square is equal to CO square plus DO square. This is equation 3. Next, AD square is equal to DO square plus AO square. So we got all the 4 now. Now add all the equations 1, 2, 3 and 4. LHS separately, RHS separately. LHS AB square plus BC square plus CD square plus AD square is equal to AO square. I don't have a place, children. You can write all the terms together, but I am counting it. See, 2AO square plus 2BO square plus 2CO square plus 2DO square, children. So next step is only LHS we have got already what we are to prove. Only RHS will take now 2AO square. 2AO square plus 2CO square will give us. We'll see now 2AO square plus 2CO square. So what do you get? Plus 2BO square plus 2DO square is equal to 2 if you take common, what you will get? AO square plus CO square you will get. Again if you take 2 common, or overall if you take 2 common, then you will get plus BO square plus DO square. So the question is, what you need to prove here is, prove that the sum of the squares of sides of a rhombus is equal to the sum of the squares of its diagonals. So AO square plus CO square will become AC square. Yes, children. So LHS as it is you need to write here. Okay, when we are proving something we have to write here. I am continuing with the RHS. Now AO is half of AC. So you can write now half of AC whole square plus CO is half of AC, that is also whole square. I am going to rub this all. Similarly, BO is half of BD square plus DO is also half of BD square. So this becomes now 1/4 of 1/4 AC square plus 1/4 AC square plus 1/4 BD square plus 1/4 BD square, children. So overall I am going to take now, so 1/half of AO square is half of AC square. So this becomes now 1/4 of AC, 1/4 of AC becomes, it is half AC square plus half BD square. So 2, I am going to take 1/2 common. In the bracket you will be left with AC square plus BD square. 2 gets cancels. So you will be left with AC square plus BD square is equal to, you have to write here AB square plus BC square plus CD square plus AD square. Sum of the squares of all the sides of a rhombus is equal to sum of the squares of its diagonals. That is how we proved the 7th question, children. This was 7th question. I rubbed it. So do subscribe my channel so that you can see all the videos. Thank you. We'll meet you in the next video.